All right. Thanks, Phil. That was great. So yes, I actually started with VANTIQ about 3 years ago, and I've been to 3 Engage Canada events. This is my 3rd one in a row. I always love coming to Canada. VANTIQ is located in San Francisco Bay Area in Silicon Valley, but I am actually a Canadian. I can prove it. Okay? So oh wow. Yeah, they didn't clap for me before. I don't know why. But yes, I am actually a Canadian. But my American colleagues are also very polite, very friendly. You'll have no problem talking to them as well over the next couple of days. And we are going to talk about, I think actually Nigel's presentation was a great setup for what we're going to talk about now, because he listed so many interesting changes in the way work is going to get done, and I expanded a little more broadly into business operations in general. And I think myself and VANTIQ think about fundamentally digital transformation is really about thinking about how you're going to transform your business operations to do things in real time. And I'll give some real examples of what that means in a second. I'm going to spend most of this presentation talking at a pretty high level about event-driven architectures and real-time applications, and then hopefully, obviously, over the case study workshops and the one-on-ones, we'll be able to dive a bit deeper. So the overlap slide, I guess, with the previous presentation, we all know that business is changing rapidly, right? A lot of core technologies are driving that change. IoT, AI, machine learning algorithms, object recognition, facial recognition are sort of subsets of AI and machine learning. And then increasingly, we're seeing a lot of edge computing applications, especially driven by IoT. You just can't possibly take all that data flowing off all these sensors, devices, cameras, and have it all go up to a central application in the cloud. It increasingly does have to be processed on the edge. And that's really been a big change over the last couple of years. I'd say 2 years ago, almost any edge computing installation that I saw in the real world was done by the innovation lab or the science group or something, and now they're being done, in core IT. And of course, those are just technologies. The business model changes that we're seeing are, moving from buying products to people paying for outcomes, right? And they're renting those outcomes, actually. They aren't buying them once, they're renting them over time. Everything as a service is what our businesses are rapidly transforming into. It's really a meshing of the physical world with the virtual world now increasingly. But out of all of those, I think the one which is most fundamental to many digital transformation initiatives is this one. It's moving from what I think of as a batch mentality toward a real-time mentality. And what does that mean? Think of what Uber did to the taxi industry. The taxi industry used to be a batch industry. You'd phone in, talk to somebody, they'd put your name on a list. Eventually, when they got to you, they'd look to the list of drivers that weren't available, weren't being used at that point in time, try to do a match. If you were lucky, half an hour later, somebody came to your house to pick you up. Uber fundamentally transformed that business because they know the real-time status of every driver, every client, every person who's been picked up or not, the condition of every vehicle, if they're going to have to stop for gas in 15 minutes or not. They have all that data flowing in real time, and they can make the kind of decisions that would totally disrupt a multi-billion-dollar industry. That is how you radically transform business models and transform your business operations, is take a process or a system that used to run in batch mode, gather some data and make an action later, and transform it into real-time mode. As the data is flowing in, take an action now. And we're going to talk more about how you actually do that. By the way, this notion of real-time data, I found this interesting, an IDC study. In fact, by 2025, 50 zettabytes of data will be created. A zettabyte is 1 billion terabytes of data. I know you all knew that, but it's 1 billion terabytes of data. But the most important thing is the 30%. 30% of that data will be analyzed and used in real time. It's not just about putting data in databases, then data warehouses, then data lakes and data oceans. It's about taking that data, flowing off these devices, the systems that are running in and around your businesses, and doing something with it while it flows. Now, another shout out to my friends at IDC, and I used to also work for Corel Corporation in Canada, and IDC, I did a number of big projects with them over the decades. One thing they're doing really cool now, if you're not already an IDC client, is this digital transformation use case database. So they've compiled a database of, in fact, this data is almost a year old. They now have almost 1,000 different specific use cases by industry and by department or organizational area for how you can transform that part of your business operation. And when I analyzed this database a few months ago, well over half of these transformational use cases involved taking a process that was done fundamentally in batch mode and moving it to some kind of real-time system, taking an action now while that action was most valuable. When I think about digital transformation, this is exactly what I think about, and this is a great tool. So thank you, IDC, for creating this. So obviously, there's some challenges we're all facing, though, right? Complexity increasing, agility, speed. We've got software everywhere in and around our organizations, all these new technologies we've just talked about. We're going to talk more about human-machine collaboration in a second, very critical to Nigel's presentation. But fundamentally, the success of our business operations are mostly built around people. How can we make our people more efficient and effective? And this notion of a lights-out factory where all the people, go home, we're not anywhere near that for most of our business operations, as you know. And then finally, we've got maybe decades of legacy applications, hardware in our enterprises, software systems that we've built or bought, and somehow we've got to make all this work so we can sense what's going on around our business, analyze it, and take an action in real time. It's not easy. I know I'm not telling you anything you don't already know. Well, I'll tell you one thing. You're probably not going to do it by building yet another 3-tier database-centric application. Okay? Applications that are fundamentally built around, again, taking data, putting it in a database, and then running reports or take action later. You're going to have to do this with something called an event-driven architecture. EDA. That's how you build these real-time applications. Of course, they still might be connected to a database. You have to store something, historical analytics. That's fine. I'm not saying databases are dead. Don't get me wrong. But to be able to analyze that data as it's flowing in real time, you need to use a different mindset in terms of many of these core applications to build the next Uber of your business. So how do event-driven applications fundamentally work? You start with the data that's flowing in. Might be flowing in off, sensors, IoT devices, cameras that enabled by machine learning, facial recognition algorithms, business systems, maybe POs spinning off your global ERP systems, mobile devices, your workers doing things. These are all events that are flowing in and around your organization, and these events might be the status of systems or machine, the locations of vehicles or people, various other external conditions. Any of these things could be events. And fundamentally, an event-driven applications need to be able to process that data as it flows in. Again, not put it in a database for later, but look at it, see if there's anything important there. And the way it knows it's important is you've built into the application some rules, some constraints. You know that if the air conditioner you're monitoring gets above 75 degrees for 3 minutes in a row, that's going to predict a future breakdown situation. Maybe you have the schedules for the service technicians pulled from the ERP system. So the application understands some of these rules and constraints, probably also connected increasingly to machine learning or AI algorithms to make predictions. And then finally, and here's the most important thing of this whole thing, if you can take one thing away, it's about the actions. It's about taking actions in real time. This is where the value is. A lot of IoT-connected systems and IoT platforms create really nice dashboards. And maybe you have some of those dashboards running in your businesses today, dancing charts and graphs showing the state of systems, and then a person sitting in front of that screen looking at them, trying to make sense of it. Dashboards are great, but if you can actually build applications to enable complex actions to take place, where your people and your systems, your machines are working together collaboratively, that's where the real power comes, right? That's what Uber is all about. It's not reporting to somebody to do something, it's having them actually do it, right? Take that action with that car in real time. Let me give you mostly a real example here. So imagine that you've been awarded the contract to do the field service for a number of major buildings' AC units in your city, okay? And by the way, the average commercial HVAC unit now has 120 sensors on it, putting off data every second. All right, temperature, pressure, wind, external, internal, all of that is being recorded by these commercial HVAC units. You've got the contract to fix these things, hopefully to prevent them from breaking in the first place. And you've got a bunch of third-party contractors who are your service people. They aren't your employees, but they're people that you have running around working for different companies that could theoretically do the actual service in the real world. It's a very common situation. So imagine you have all that data flowing up. It's probably not going to flow all into one central cloud. Too much information going. Could be gigabytes of data every day. So there's probably an edge node running in the building, okay? It's just taking those readings, 72 degrees, 78, 82, 90, uh-oh. Now your algorithm is predicting there's going to be a problem. Now is when you spin that event off to the central application. It looks at who the current service technicians that are on call right now and are available, and it uses the real-time GPS location of the three to find the three closest technicians, poll them for the job, and see who's available and who takes the job first. When one of them does, that person is directed to the exact building, given instructions how to access the AC unit. But while she's on the way there, the piece of paper that was blocking the vent blows away, AC unit cools back down, and the whole system stops and resets, sending the service technician somewhere else. Imagine how that whole end-to-end flow would happen most times today, right? AC unit goes out, we start getting hotter and hotter. A few hours later, finally somebody calls building management. They get on a list. Hopefully by tomorrow somebody looks at it. The first time the service technician comes, she doesn't have the right tools on her car because she didn't know what the problem was in real time. She has to go back and get new tools. It's basically inefficiency, cost, and lack of customer satisfaction. This is a real-time system that addresses those problems. So I am a former Gartner analyst, so I do have a few Gartner slides here. Apologies to my IDC friends. But Gartner and IDC and many others have been doing a lot of writing in the last couple of years about event-driven architectures, EDA. It's actually not a new thing. These systems have been around for decades. Real-time airport control systems, and many of your businesses are using real-time systems. But as we'll talk about in a minute, what's really changed is how easy and quick it is to stand up these kind of systems today compared to what it used to be. Lots of different use cases, and we'll talk more about these tomorrow, but really any use case which has the word intelligent in front of it, or real-time in front of it, or smart cities, smart buildings, real-time field service, you name it. In many cases, these are event-driven, real-time applications. All right, so our friends at Rolls-Royce created an interesting video. Maybe some of you have seen this on the web. I really like it. It's a little bit futuristic, and sometimes I'm reluctant to show it because people get a little overwhelmed by the high production value of this video. Rolls-Royce has a lot of money to spend on nice fancy videos. But keep in mind when you watch this video here of a real-time event-driven application, almost everything you see in here is real today. These technologies, one or more, or sometimes many of them, are running today in real-time applications that are powered by VANTIQ with our clients today. So obviously it's a real-time system. There's big touch screens. We've all got those, right? Text to voice and natural language processing. We've all got Siri on our phones. There's nothing really new there. Real-time GPS tracking of people, of objects, ships in this case. Augmented reality video overlays. Yeah, a little cutting edge, maybe still a little expensive, but not crazy. Drones, increasingly, we're seeing many clients starting to use drones, monitoring oil field problems, you name it, facial recognition, eye tracking. But the only thing in this video which you can't actually do today is these 3D holographic images you're going to see without goggles on. If you got HoloLens or something, you can even do that today, no problem. But they get a little carried away with the 3D thing. But let's take a look at this very cool example of a real-time event-driven application that uses many of these technologies that we've just been talking about.
The control room is the nerve center of remote operations in the Rolls-Royce OX concept, where the global wall shows a real-time overview of worldwide shipping traffic. A full situation overview is presented to operators who are monitoring vessels via remote link from their onshore workstations.
Dynamic Positioning reports DGPS-1. Lost connection for vessel RR9835. Suggested course of action. Diagnostics. Commands?
Proceed.
GPS, geopositioning and celestial navigation status. Nominal. INS status. Transmission stopped. Suggested failure mode, physical. Commands?
Stand by. I'll have a closer look.
Drones 01 through 08 ready for inspection flight. Commands?
Launch drones 1 and 2. Flight plan. Standard inspection routine. Camera control. Manual with eye track. Deploy replacement for selected antenna. Schedule post-mortem inspection and change of antenna at next port of stop. Add checkpoint for operator at selected time. Verify navigation data integrity.
The vessel is ready for handover to local operator at West Coast BTS. Transferring administrative documents. Suggested course of action, break and refreshment.
Okay. Leave the documents open when they're ready.
Confirmed.
All right, I want the virtual cup of coffee. We know we've reached technology nirvana when we've got that. So anyway, by the way, a really great example of human-machine collaboration. It's not a lights-out control room with an AI, generally intelligent bot making all these decisions, right? It's a person applying their wisdom and experience working with these intelligent systems. The whole video is actually about 15 minutes long, so if you're interested, they get into many different use cases and scenarios. You can take a look. All right, so let's wrap it up here talking a little bit about what are the most important elements of a platform that enables these real-time event-driven applications to be built. Obviously, at the core needs to be an event-driven architecture. Applications need to be mission critical. We'll dive into a little more in each of these. Distributed edge computing we talked about. Human-machine collaboration is important. And then finally, how quick and how easy it is to build, deploy, and manage these things, which is, I'm sure, mostly what you're thinking about. By now, you've probably got some idea of why it is important to think about applications that have this notion of an event-driven architecture at their core if you truly want to build that next generation of transformative applications. I don't have to talk about that anymore. One thing about these applications, EDA-built systems, is they're loosely coupled. They tend to be scalable in a way that building, monolithic applications isn't. So if you need, in fact, at VANTIQ, we say POC has like one of those circles and a red line through it. Nobody really builds a POC with VANTIQ because when you build one of these systems, it may be a small use case, but it's inherently secure, scalable, and always unavailable right from day one. Okay. In fact, I've never seen a case where somebody throws away a POC and then begins building the real thing. No, the first application is the real thing. There is no POC with these kind of applications and architectures. Edge computing, we talked a little bit about, really important. And we see, as I said before, this is coming out of the science lab. Also, probably a third of our clients are still actually running in the private cloud. I know, we've seen a lot of data and studies showing embracing the so-called public clouds are the way to reduce IT costs, increase flexibility. That's great. We also know that for some clients, they just need that I think it's more a feeling of security that comes from running in your data center in a private cloud, and your application platform should be able to do that as well if necessary. Human-machine collaboration, right? As Accenture said, companies that embrace AI systems collaborating with people are going to be the ones that show the lion's share of revenue growth in the next 5 years. And I think we can all see that in the future of work discussion we had supported that. But again, this doesn't mean lights out, goodbye people, right? Can anybody tell me who wasn't here last time I gave this presentation, what this is a picture of? Anybody know offhand? Whose assembly line this is? This is Elon Musk's Tesla Model 3 assembly line. Okay? The definition, supposedly, the definition of robots and intelligent machines taking all the actions, making all decisions, and you can see he's not quite there yet, right? Because he realized when he had to actually bring up the production volume and get this thing humming, he needed people, intelligent people, and intelligent machines and robots working together at the same time. Human-machine collaboration. All right, so I'm sure it all sounds great, Blaine, but how do we actually build these things? It sounds very hard, and you're right, historically it has been quite hard to build event-driven applications and systems, right? All these events flowing in asynchronously, streaming in real time and massive volume, increasingly distributed around large footprints. And then, of course, as I keep saying, most of these applications involve people. And once you put people in a system, everything just got more complicated, right? They're unpredictable, they do things at any time, they're uncontrollable. And so how do you create applications that handle this kind of thing in real time? How do we know what the Uber driver is going to do next? We can't predict that, right? Well, here's how they used to build these applications. So this middle part here, obviously based on an IBM platform, but it could be based on any platform. This is not a knock at all on IBM. But this is just an example of a real-time global supply chain application built by a retailer who you know, actually. And you can look at the different core technologies that they built their application on top of. To do this, they had to have guru-level developers who knew each of those systems, knew how they work, how to be tuned and scaled, how to connect them to other technologies, then how to build applications on top of it. And when one of those systems or tools changes, then you got to retest and recertify the whole entire application. Now, if you're a massive global retailer, you can afford the very large teams of gurus to make this happen. But even if you could afford the team, as these guys definitely can, these guys, I guarantee, can't afford the time anymore. The pace of change is too quickly. The pace of transformation. Nobody has 2 or 3 years to build a system like this. Right? Nobody has it anymore. It doesn't matter how big your company is. You need to be more agile, more real time. So luckily, it's not as hard as it used to be. Okay? A new breed of high productivity, so-called low-code application tools are now coming. Obviously, this is what VANTIQ is. That's why I'm here talking to you about this. Combining this notion of low-code application development, and that's been around for a couple of decades now, right? You may know some of the companies, Mendix, OutSystems, Appian. Maybe you're using some of them in your organization now for cloud migration of applications or mobilization. It's all fine. But the good news is that idea of rapidly building, usually visually building applications has now been applied to this world of event-driven systems. Not just database-centric 3-tier applications, but event-driven applications. So you can rapidly build, deploy, and then manage, update, enhance those kind of applications, the ones we've been talking about for the last 20 minutes. And as IDC says, this kind of light no-code approach, this is obviously critical to being competitive now and in the future on an ongoing basis because things are moving so quickly. And now that we can apply that to EDA, that's where the real digital transformation will happen. So the current method, teams of developers writing thousands of lines of complex Java, reactive Java code. And the new method is to be fast, agile, using visual application development. And you'll see, again, in the workshops, more of this actually happening in the real world tomorrow. No more slides. You get to see it happen in the real world. And that actually is all I'm going to say about event-driven architectures and real-time systems in VANTIQ today. Do we have, I'll just flesh this out. There you go. Do we have time for a couple of questions, Phil? All right. Questions about real-time, EDA. I can talk about VANTIQ as well, although we'll have lots of time to talk about that in the next couple of days.
Any questions? Yes.
Yeah, there's one over there.
you please just your name and company, please?
Paul Panelides from Zebra Technologies. I understand the human interaction element that you're proposing, but the human is actually the weak link in a lot of these systems. How do you address that?
Well, you have to find, that's a really great question, and you have to find the scenarios where the person actually adds value instead of detracting value, right? So just maybe to go one more slide here, it's a very interesting use case of client in China. By the way, we talked earlier about China, about how far the US, Canada was compared to the US in these kinds of technologies. I think that's the wrong analogy. Canadians should be looking at how far ahead China is in the use of these technologies. 1/3 of our business this year will be in China, right? Doing use cases exactly like this. I mentioned the idea of AC units connected through IoT devices to real-time field service. Well, this is sort of the same use case. It's with elevators. Already running with 5,000 elevators in the city of Shanghai. By next summer, it'll be 250,000 elevators, every single commercial elevator in the city of Shanghai. They'll be doing real-time field service through a VANTIQ application for every single commercial elevator. Only in China can you do that kind of thing, but it shows what's possible with those systems. And what they're trying to do with this application is, instead of having all these people basically sitting around all day waiting for an elevator to break, or waiting for somebody to spill something on the floor, or waiting for somebody to drive their motorcycle into the elevator, and I've seen this in real time in this VANTIQ application, some crazy stuff that people do in elevators, very low value task for a person. Now they're letting the system handle all that, and they're only involving people with high value tasks. Like, how do you then go, once the elevator is predicted to break down in the next hour, bringing a trained technician in to address the situation before it breaks down, right? It's not eliminating people, but it's using people where they're going to actually add the most value. And I think, in powerful VANTIQ applications, that's how they're not really thinking about it. There's almost not a single VANTIQ application I can think of, truly, that is a lights out, no people involved application. They're all about how do we better use the people. But one more quick example. So for physical safety and flood alerts in the city-state of Belgium, right? How they used to use people? Belgium's always getting flooded. So they used to use people very inefficiently, right? They'd have people standing on sidewalks telling people where to go. It's flooded over there. You can't go back to your house. Now people have mobile apps. They know exactly where the flooding is predicted to occur. If a aid station is full of people, they use the object recognition to tell how full the station is. The app will automatically send people to a different aid station. And when an attendant is typing in directions into the master application, it's automatically translated into 4 languages in real time, right? So it's not eliminating people, but it's using people more effectively, more efficiently, or public safety, security, police, fire in Belgium. Thanks. Great question.
Any other questions? Thank you, Blaine.
Okay.
Blaine and his team will be here over the next 2 days, and you'll be hearing a lot more from them. And thank you so much, Mr. Mathieu.
Thank you.